This video is sponsored by Train World, America's discount model train store since 1968. Hey everybody, it's Jimmy from the DIY and Digital, and today we're adding some new features to the Arduino grade crossing project. Welcome back everybody. First of all, if you haven't already, go ahead and hit that subscribe button so that you are eligible for the 10,000 subscriber giveaway sponsored by Train World. The folks up at Train World and Trainland were nice enough to provide me with some cool prizes to give away for you guys. You should definitely check them out at trainworld.com. They have a wide selection in all of the major scales. I'm talking N, HO, O, G scale, all sorts of different stuff there. Very, very wide and wonderful selection. Go ahead and check them out at trainworld.com. And thanks again for sponsoring the 10,000 subscriber giveaway. I'm going to be announcing how to enter as well as the prizes I'm going to be giving away in the coming weeks. So you'll definitely want to be subscribed for that. So today we're going to be working on improving the Arduino grade crossing project. There's been a few different things that you guys have requested. I'm not going to be able to do everything that's been requested as an improvement to this project, but I'm going to be adding a cool new feature to this project, which is going to add a lot more realism and another really neat thing that this project can do. So let's go ahead and get started. When I set out to update the crossing sketch, I wanted to add the ability for a crossing gate to raise and lower. This is a simple enough task for an Arduino to do. The trouble came when I tried to have the lights flashing and the crossing gate go up and down at the same time. Now this is a simple problem to remedy for a coder, but my coding knowledge, like most of you, is fairly limited. So I wanted to figure out a way to do this without complex code. That's when I remembered circuit board flashers. Circuit board flashers are little circuit boards that you hook two LEDs into and they flash when power is attached. So this made everything easier, meaning all I had to do was turn the power onto the board and the flashing lights would just go. Now we can start the build. Here are the supplies you will need for the prototype: an Arduino, 2 infrared sensors, a circuit board flasher with 2 LEDs, 2 linear servos, a breadboard, and some prototyping wires. We start by connecting the power from the Arduino to the power columns on the breadboard. Next, we place our sensors. We connect the sensors G and D to our ground, VCC to our power, and out to the sensor output, in this case A0 and A1 on the Arduino. Next, it's time to wire up the flasher. We connect the ground to our common ground and our power to digital pin 6. Now we can hook up our linear servos. First, we connect pin 9 to a row of pins on the breadboard. We then hook up our leads to the servo. We connect our ground and power, then connect our output to the row with the pin 9 wire. And then we repeat the process for the second servo. Okay, we are all wired up, and now it's time to go write some code.
Okay everyone, we are in our Arduino IDE and let's get started. So the first thing we need to do is declare some integers. So we're going to do integer since pin 1 equals a 0. We'll go ahead and say declares A0 as our sensor 1 input. Then we'll do sense pin 2 equals A1, and declares A1 as our sensor 2 input. Then we're going to do integer flash equals 6. That's our control for our flasher, and this is where it's going to get a little different. We're going to do include servo.h. That's going to add our servo control library. Now we're going to do integer flash count. And that's for counting our flash cycles. That'll come up later. Then we're going to do integer position 90, which is going to be, it's going to be our start position for servos. And then we're going to do servo equals, well, no equals, my servo. And that names our servo control. Okay, now we can go ahead and hop into our setup. So we're going to do void setup, parentheses, and go ahead and bracket it. Then we're going to do serial.begin 9600. And that's going to enable serial monitoring. Then we're going to do pin mode, flash, output. And that is pin 6 as an output pin. Then we need to do my servo dot attach. Then we're going to say 9. And this sets up pin 9 as our servo control. Okay, so that's everything we need to do right there. So now we need to enumerate our crossing states. The first state we need to do is st underscore off. There's going to be 7 in total. St underscore flashing 1. St underscore flashing 2. St underscore flashing 3. St underscore flashing 4. St underscore flashing, oops, almost typed too much there, on 1. And St underscore on 2. And then this identifies our 7 crossing states. Now we need to say crossing states, crossing state equals st underscore off. And this is our default crossing state. Okay, so that's it for all of our setup. So now we can go ahead and hop into our loop. So we're going to do void loop. We're going to start off with integer value A1 equals analog. Oh, gotta get my formatting right. No capitals on the analog. Analog read since pin 1. And this reads sensor 1. And value A2 equals analog read since pin 2. And that reads sensor 2. And we'll do serial.print ln value A1 and serial.print ln value A2. I almost forgot my semicolons right there. And what this does is it prints the values in our serial monitor for prototyping. And then last but not least, we're going to put a delay of 200 because we don't want to be reading this 1,000 times a second. Next, we can go ahead and do our switch. So we're going to do switch crossing state do case st_off with a colon and do crossing off value A1 and value A2 and break. Now what I'm going to do here to save a little bit of time is I'm just going to copy this because we're basically just going to repeat this. I'm going to do this and then I'm just going to change it to flashing 1 and change that to flashing 1 and we'll neaten it up a little bit, format it. Then we'll switch it to flashing 2. Then we'll switch this one to flashing 3. And then we'll switch this one to flashing 4. And then we'll switch this one to on 1. And then on 1. And I'm going to copy paste that again to on 2 and on 2. And there are our 7, let's count them, 1, 2, 3, 4, 5, 6, 7 crossing states. So now we can go into the individual loops of those crossing states. So we're going to start off with void crossing off. Integer value A1 and integer value A2 and go ahead and do our brackets. So the first thing we're going to do is we're going to do digital write flash low, which will keep the power that keeps the power down on our flasher board. Then we need to do a delay of 200, and we're going to do flash count equals 0. And what this does is this resets our flash counter. And that is important for later on in the sketch. So now we need to do if value A1 is greater than 200 and value A2 is less than 200, crossing state equals st underscore flashing 1. And that's for if since pin 1 is triggered. Next we need to do, we can basically take this and we can copy and do a little bit of formatting there. And then we just need to reverse. So if value A1 is less than 200 and value A2 is greater than 200, that's going to send it to sense pin 2, or send it to flashing 2 rather. So that's it for crossing off. So let's go ahead and we're going to highlight this little section right here. And we're going to start with void crossing flashing 1. So the first thing we need to do is we need to turn on the flasher board. I'm going to say turns on the flasher board by typing that little high right there instead of low. So here's where it differs a lot from the previous sketch. So what we're going to do is we're going to do for POS equals 90 and POS is, and that's short for position, by the way, not what else it means. And POS is less than or equal to 180, which would be the furthest opposite on a typical servo, but it's going to be the end turn of the servo of the linear servo. So we're going to do that, and then we're going to say position plus equal to 1. Okay, so what that does is the servo goes from 90 to 180 degrees in steps of 1 degree. And now we're going to do my servo dot write POS. And what that does is it controls the servo. Then we're going to do a delay of 15 milliseconds, which is and then we're going to do crossing state equals crossing on 1. So basically what this is this just something that's going to hop to temporarily while the gate is lowering for the crossing. So what we can do now is we can go ahead specifically for crossing 1. And I do, so what this is basically, we need to do one more thing here. Put that there, just to close up the loop right there. And then what this basically is this is the gate lowering while the light is flashing. This is my solution to that without a ton of complicated code by using that flasher board. So now we just need to copy paste that for crossing or for flashing 2, and that's going to go straight to crossing on 2. So exact same stuff, just going to crossing on 2. Okay, so now we're going to go and type our crossing on 1. So we're going to do void crossing on 1 value integer, forgot about that, value A1 and integer value A2. So what we need to do for crossing on 1 is first of all we need to do digital write flash hot. So this keeps the flasher on. A reminder, if you're doing these sketches, especially people who are new at Arduino, you do not have to type these lines. I just typed this because this is the exact sketch that I'm going to send out for you guys to be able to download, so I go ahead and put the notes in for you guys. Next thing we need to do is do a delay of 1,000. So this is a 1 second delay because Arduino measures time in milliseconds. Then we need to do a flash count plus plus, which you remember we reset our flash count to 0, so this adds 1 to the flash count. So maybe flash count equals 1 second, flash count equals 2 seconds, flash count equals 3. It's basically a way of counting up. So now we need to do our if-then statements. So first one we're going to do is if I can type that right, value A1 is less than 200 and value A2 is greater than 200, go ahead and put our parentheses in our bracket. We'll do crossing state equals st underscore flashing 3. So we're going to do this as switches to flashing 3 if the exit sensor is tripped. Else if value A1 is greater than 200 and value A2 is greater than 200 and flash count is greater than 5, do crossing state equals st underscore flashing 4. So what this is So this is a special contingency for if the train is shorter than the distance between the crossing sensors or is sitting between the actual sensors. So if, like, let's say the locomotive just pulls in and stops, it's going to go to flashing 4 after 5 seconds, which is why the flash count needs to be greater than 5, which is why we have this plus plus. So now we need to go and basically do this over again. So it's going to be crossing 2. And then we just need to reverse our greater thans and less thans right there. And then everything else is the same. So now we need to go on to flashing 3. So we're going to go void crossing flashing 3, integer value A1, integer value A2. Just going to go ahead and copy this. So because we are going to have the flasher on during this, and we are going to want a delay of 1000, so I'm going to go ahead and copy that as well. So one thing we need to do really quick, actually, because I completely forgot to do this, is we need to do flash count equals 0. So this will reset the flash count right here when it switches over to flashing 3. Because we're going to need the flash count here as well. So now we need to do if value A1 is greater than 200 and value A2 is greater than 200, and flash count is greater than 5, so it's been going for 5 seconds, we will need to run this. So what we're going to do is we're going to run our servo again. So we're going to 4 POS, remember position, 180, and POS is greater than or equal to 90. POS minus equal to 1. So this goes from 180 to 90 in increments of 1 degree. So now we need to do my servo.write EOS and a delay of 15. I'm going to do a bracket. We do a delay of 1,000 and crossing state equals st underscore off. And that's it for crossing flashing 3. And now we need to write flashing 4. So we're going to do void crossing flashing 4 integer value A1, integer value A2, and do digital write. We're actually going to go ahead and copy all of this. So I know here when I go to flashing 4, I do not reset the flash count, and that's okay in my opinion for the reason that the flash count exists in flashing 4. So like I said, you do not see me resetting the flash count. I actually do need to also, one thing I missed here is I need to do flash count equals 0. So that flash count resets and crossing on 1. That's one thing I did forget to do. So now we have the basis of this. So what we're going to do is we're going to do if value A1 is less than 200. Then we're going to do these two bars, which is your / shift / which is above your enter key. Or value A2 is less than 200. This is going to take it right back to, we're going to do flash count equals 0. And then we're going to do crossing state equals st underscore flashing 3. Then we're going to do else if flash count is greater than 120. Do crossing state equals st underscore off. And this prevents infinite looping by cutting the signal I'm going to do else if flash count is greater than 120. Now we have else if flash count 120. All we're going to do is we're going to take our for statement that was the exact same one that raised the gate in flashing 3. We're going to put it right here for flashing 4. And what that will do is send us to, all we have to do is add crossing state equals st underscore off. And that is a full reset. So let's go through this really quick. We have all of our integers being declared, and we added our servo library and declared what our servo was, my servo. And in the void setup, we had our serial begin, so we can do serial monitoring, pin mode, flash for output, so that pin 6 that we used is an output pin, along with attaching pin 9 to my servo, so that's what's going to control it. We enumerated our 7 flashing states, state off, flashing 1, 2, 3, and 4, as well as on 1 and 2. And then in our loop, we set up the reading of our sense pins and printed them out onto the serial monitor. And then we set up the switch to our different crossing states. And then crossing state off, we set up our switches to flashing 1 and flashing 2. And then those were set up to go to on 1 or on 2. And then these are set up to either go to flashing 3, which is a longer train leaving and heading out of the crossing section, and then turning it off, or flashing 4, which is for a smaller train which may stop or be smaller than the entire section of the sensor area itself. So it's either going to switch back to flashing 3 to finish turning off, or it's going to get to, in this case, I set it to 120 seconds, but you can change that right there to any length of seconds. And then it will turn itself off by when it goes over 120 seconds. So let's go ahead and give this a check. And there we go, a few little typos and errors fixed. I do type these live to record. So there you go, and go ahead and upload this.
Okay, we've uploaded the code and now it's time to test it out. Voila! The lights flash at the same time as the servos move. So that's the modification to the Arduino grade crossing project that we made. We added it to where you can put in servo motors and raise and lower crossing gates, and that just adds another level of realism to this project. So thank you guys so much for watching, and if you haven't already, go and hit that subscribe button so that you're eligible for the DIY and Digital 10,000 subscriber giveaway sponsored by Train World. And while you're at it, go ahead and hit that like button and hit that bell icon so that you don't miss any updates like this video. Until next time, I'm Jimmy from the DIY and Digital. Happy railroading!